Hello everyone, the Forensic Junkie here again. I'm going to be showing you all how to create a forensic image of a storage media using FTK Imager. Now, a side note, I created a video last week showing you how to create a software write blocker using Windows Registry, and it's going to be very important. So, if you've not watched it, the link is in the description. And if you have, but your write blocker isn't enabled, please do so before you plug in your storage device. So enable your write blocker in Windows Registry. Let's begin. So here is the FTK Imager environment. And I made mention of a forensic image. What is that exactly? A forensic image is a container that is used to preserve evidence to make sure it's an identical copy of the original evidence to prevent tampering. This is a very important aspect in the forensic process because you want to preserve evidence after identifying it. You don't want it to be compromised. So let's get started. I will be imaging my 2 GB flash drive connected to this computer. First off, we will click File and go to Create this image. Now you're going to see a dialog box showing you physical drive, logical drive, image file. But we want a physical drive. What's a physical drive? A physical drive means a bit by bit copy of our storage device. In this case, I want a bit by bit copy. I want an image showing me not just the files and folders on this drive, but the unallocated space, the various partitions, even the deleted partitions. But if I choose to click on logical drive, I only get the files, the files and the folder alone. I don't get the unallocated space or any deleted partition. It doesn't show me that. So as a forensic investigator, you don't want to leave any stones unturned. So you will choose physical drive. Sometimes evidence, data can still be left in those deleted partitions. You want to know what happened, what was stored in there. So next, we're going to click to choose the flash drive, finish. Now, the destination of our image, we're going to click add, and here we have different forensic image formats. The first is raw or DD. The second is Smart. Then we have EO1, AFF. We're going to choose RAW. Smart is a Linux utility forensic extension. EO1 is the extension used by NK software, another software just like FTK Imager, except that that one is proprietary. You have to pay for it. It's also used to analyze evidence, make forensic copies of images. AFF, Advanced Forensic Formats. And this also another extension, another way of. So you click next. Now we see case number, evidence number, unique description, examiner notes. Every forensic software you use tries to make sure that chain of custody is followed because it assumes that evidence must be protected and follow the chain of custody format. It assumes that evidence is to be presented in the court of law. So there's so much detailing to be done. So the case number, we're going to call this case number 001. evidence number, item 007, then the unique description, 2 gigabyte flash drive. The examiner, forensic junkie. Notes. The note for this imaging will be imaging of a 2 gigabyte flash drive. Next, now image destination folder. You want to make sure that the destination of your image is larger than the image itself. For example, the size of this image is 7 gig. We cannot make our destination somewhere smaller, let's say 2 gig. It has to be larger. So I want the destination of this image to be a desktop. In your own case, you might want the destination of this image to be an external hard drive connected to your computer. So desktop, I'm going to choose forensic image 001, the folder. Okay. Then the image file name, that will be uh, 2 gigabytes flash. Image fragment. FTK does this where it fragments images that are very large. For example, I'm imaging a 1 terabyte flash drive or maybe a 2 terabyte flash drive. It's going to be a very large image. So you can fragment it. And in this case, the fragment size is 1500. But then in the case that you are imaging something that large, you want it to be bigger than 1500 so that you don't have so many images and so that it takes less time. So since we don't have any business with that, we're going to click finish and verify images after they are created. FTK is going to verify the images using hashing. So it's going to use various hash algorithms, SHA1, D5. You're going to see that after the imaging is completed. And then we're going to check, it's already checked. We're going to check pre-calculate progress statistics. That is going to tell FTK to show the progress of the imaging. We may not necessarily need it because we are imaging a flash drive that is very small. But in the case that you are imaging a 500 gig hard drive or 1 TB hard drive, you do well to tick this because I mean everyone wants to see their progress. So we're going to click start. Right, now it's complete. And remember we chose to verify. So in forensics, we have something called hashing that we use to verify the integrity of a file or an image. So the computed hash was this for MD5, and you can see there's a match. Same for SHA1, there was also a match, and it checks for bad blocks. There were no bad blocks found in this image. So which means our image wasn't compromised. Now close, minimize. Let's check the folder. So here it is. This is our image. You can see here is a documentation, the case number, the evidence number. You can see everything written here. And it shows you even down to the number of cylinders of the drive, the tracks per cylinder. It shows you the serial number of the flash drive, 64CE4123. So a lot of information is here and has to be documented. It also shows you the version of FTK that was used to carry out this examination in case it is called into question and needs to be re-examined again. Like I said, digital forensics is a very sensitive field. We're dealing with evidence and we must do our due diligence. So that's all for this video. Please do well to like and subscribe.